Welcome, everyone. Today we are exploring a paradigm-shifting concept in modern cybersecurity, cross-domain attack paths. As artificial intelligence evolves, adversaries are no longer confined to single environments. They are chaining vulnerabilities across cloud, operational technology, and even space assets. Let's get started. Let's dive into our first concept, cross-domain attack paths. What exactly are these? By definition, they are sophisticated attack sequences that span entirely different technology domains, traversing boundaries that were previously thought impenetrable. The basics are critical to understand. A modern attack doesn't just stop at the cloud. It moves from cloud and enterprise IT into identity structures like Active Directory, pivots into IoT, breaches operational technology, leaps across tactical RF waves, and can even reach space assets like satellites. But why go through all this trouble? Because our most critical assets like space arrays and industrial controls are heavily isolated. Adversaries must build these complex bridges to reach them. How is this changing today? Frontier AI models, specifically Anthropic's Claude Mythos, have demonstrated the ability to autonomously reason across all these layers, synthesizing exploit chains at machine speed. In our deep dive, we recognize that what used to take state-sponsored human hackers months to map out can now be orchestrated by a single AI agent looking at the entire system as one giant puzzle. Take a look at this flowchart, which maps out the exact six-stage sequence of a cross-domain attack pattern. It begins on the far left with a breach in the cloud and enterprise environment. The attacker performs a credential harvest to infiltrate identity and Active Directory. From there, a supply chain pivot grants access to IoT and embedded systems. This enables a protocol exploit to breach the highly sensitive OT and ICS layer. The attacker then forces a cryptographic downgrade over tactical RF, culminating in the red node, a command injection into satellite and space assets. This is the ultimate kill chain. Moving to slide 2, we address the core vulnerability in our current posture, the false assurance of single-domain defense. What does this mean? Traditionally, enterprises have structured their security in silos. You have your cloud team, your OT team, and your RF communications team. The basics dictate that this siloed model is now failing. Why? Because when you fix a bug in just one domain, an advanced adversary will simply route around it, finding viable paths through the seams between your teams. This creates what security researchers call a false assurance surface. You think you are safe, but you are completely exposed. How does AI play into this? AI models don't respect organizational charts. They view your entire enterprise as a single, interconnected graph. In our deep dive, consider this. An IT engineer might flag an IoT vulnerability as low severity because it doesn't house IT data. But the AI attacker realizes that same IoT device shares a network with an operational SCADA controller, turning a low-severity IT bug into a critical OT breach. This state diagram illustrates the inherent flaw in siloed defenses. We begin with our separate security teams. The cloud is secured, and the OT is secured. However, because these teams don't communicate perfectly, an AI discovers a seam using cross-domain logic. This leads directly to an unmonitored bridge pathway neither team was actively watching. Consequently, the system state transitions inevitably to system compromised. Security can no longer exist in isolation. Let's break down the attack path, starting with Stage 1, Cloud, Enterprise, and the Identity Pivot. What happens here? This is the initial entry point, focusing on gaining a foothold in traditional IT networks before aiming for the restricted zones. The basics usually involve penetrating an exposed public-facing cloud service or utilizing AI-generated spear phishing to compromise an employee. Why start here? Because the cloud is internet-facing, making it the most accessible layer, and it houses the crown jewels of enterprise access, identity, and Active Directory. How does the attack progress? Once the AI agent has initial access, it ruthlessly executes credential harvesting and lateral movement. For our deep dive, understand that a frontier model can do this at machine speed. It maps your entire Active Directory forest in seconds, specifically hunting for dual-role accounts users or service accounts that possess permissions spanning both the IT cloud and the restricted OT environments. It uses identity as the key to unlock the next domain. Follow the sequence diagram to see the identity pivot in action. The AI agent attacks the public cloud service to gain initial shell access. It immediately targets Active Directory, performing rapid credential harvesting techniques like Kerberoasting to obtain domain admin tokens. With this power, the agent queries AD for dual-role accounts, exposing a specific OT engineering account. The agent then uses this perfectly valid, stolen identity to authenticate directly into the OT gateway, seamlessly crossing the domain boundary. Slide 4 brings us to Stage 2, bridging IoT to OT and ICS. What is occurring here? The attacker is moving out of the digital IT space and penetrating the physical world of operational technology and industrial control systems. The basics involve using those stolen engineering credentials to compromise embedded IoT devices like smart HVAC systems or security cameras, turning them into jump hosts. Why target IoT? Because these embedded devices frequently run outdated, unsupported firmware, making them an incredibly fragile and reliable persistence layer. How is the breach executed? The AI uncovers supply chain weaknesses in the IoT firmware, takes over the device, and then abuses insecure by design OT protocols to directly manipulate field devices like programmable logic controllers, or PLCs. Our deep dive reveals a terrifying new capability. Mythos-class AI models can perform automated firmware dependency extraction. They can literally reverse engineer closed-source, proprietary binaries on the fly, discovering 0 days in the firmware that controls power grids and manufacturing lines. This flowchart details the OT compromise. Armed with stolen IT credentials, the AI compromises an edge IoT device. It conducts AI firmware analysis to extract dependencies and discover a 0-day, granting it root access on the IoT device. This device is physically wired into the OT/ICS network, allowing the AI to pivot and send malicious commands using industrial protocols. The terminal red node shows the result. Physical infrastructure is actively disrupted. We now reach Stage 3, tactical RF to space assets. What is this final frontier? It is the ultimate escalation, where the attack leaps from ground-based OT systems, rides across radio frequency waves, and infiltrates orbiting satellite infrastructure. The basics involve compromising the terrestrial ground station antennas, converting them into weapons that beam malicious code into space. Why is this the ultimate goal? Because space assets control global GPS, defense communications, and the timing systems that underpin global finance. How does the AI accomplish this? By executing a cryptographic downgrade over the tactical RF link, bypassing the satellite's authentication, and achieving direct command injection. In our deep dive, we look at how AI weaponizes modernization. As organizations migrate to post-quantum cryptography, or PQC, the AI exploits the transitional hybrid modes. It forces the system to fall back to a vulnerable classical encryption algorithm, intercepts the RF transmission, and completely hijacks the satellite's mission payload. This graph illustrates the space vector. From the compromised ground station, the AI initiates a cryptographic handshake with the satellite. It manipulates the handshake to force a downgrade to a legacy crypto protocol. With the encryption weakened, it can freely intercept the tactical RF link. The AI then transmits a command injection payload, which is received and executed by the targeted satellite orbiting asset, finalizing the cross-domain takeover. To understand how the AI traverses these highly secure gaps, we must look at the code context, bypassing cross-domain gateways, or CDGs. What are CDGs? They are the ultimate security checkpoints between classified and unclassified networks, enforcing rules at the exact byte level. The vulnerability arises during modernization. Moving to post-quantum cryptography dramatically increases the size of encryption keys and certificates. The exploit occurs when an AI adversary deliberately crafts a payload that exceeds the gateway's maximum transmission unit, or MTU. Look at our sample logic. If the payload length is greater than the allowed maximum, it triggers a truncation bypass. For our deep dive, understand the mechanics. When an oversized PQC certificate hits the gateway, the guard might panic, truncate the packet, and forward an invalid fragment. This forces the receiving system's reassembly logic into an obscure, untested code path, granting the AI a backdoor to slip its cross-domain payload right through the firewall. This sequence diagram shows the CDG bypass technique. The AI attacker sends a deliberately oversized PQC handshake to the cross-domain gateway. The gateway detects that the payload exceeds its MTU parsing limits. Unable to handle it, the gateway enters an error path, truncating and fragmenting the packet. It forwards this invalid fragment to the isolated network. The destination network's reassembly logic fails open under the malformed data, inadvertently establishing a successful, unauthorized connection for the AI. Let's apply these concepts to a real-time use case, the aerospace breach. Imagine a highly secure aerospace enterprise that controls a fleet of telemetry satellites. They believe they are safe because their control network is air-gapped. In our scenario, the trigger is pulled when an APT deploys a Mythos-class AI against them. In execution, the AI rapidly identifies a zero-day vulnerability in the company's public-facing HR portal, using it to steal a systems engineer's active session token. Now the pivot, the AI realizes that engineer recently logged into the facility's IoT HVAC system. It uses the token to compromise the air conditioning controllers inside the ground station facility, successfully bridging into the OT network. The impact is catastrophic. Operating from the ground station's OT network, the AI executes an RF protocol downgrade and transmits a rogue trajectory command to the satellite. A vulnerability in an HR website just caused a multi-million-dollar asset to fall out of orbit. This Gantt chart visualizes the terrifying speed of an AI-driven attack. It starts at hour zero with the cloud breach, where the AI exploits the HR portal and steals the session token in just 15 minutes. It immediately shifts to the OT pivot, compromising the HVAC IoT device and mapping the ground station in 25 minutes. Finally, the space impact phase executes. The AI downgrades the RF encryption and injects the satellite command. In less than an hour, the entire cross-domain kill chain is complete. To conclude, how do we defend the full spectrum? We must embrace a massive paradigm shift. Organizations can no longer defend IT, OT, and space environments in isolation. AI-enabled threats demand unified exposure management across every single domain. You must adopt true zero-trust architecture, enforcing strict microsegmentation and assuming that a breach has already occurred in your perimeter. Furthermore, human speed detection is dead. Legacy security operations centers will fail against these threats. You need machine speed detection AI-driven platforms that can correlate a cloud alert with an RF anomaly in single-digit minutes to sever the kill chain. Finally, you must deploy continuous AI red teaming, using frontier models to attack your own infrastructure and find these cross-domain paths before the adversary does. To master these advanced architectures and future-proof your enterprise, I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram is a mind map outlining the pillars of machine speed defense. It requires unified exposure to view cross-domain telemetry as a single pane of glass. It demands zero trust through strict microsegmentation and identity controls. It relies on AI automation to achieve single-digit minute response times inside the SOC. And it mandates proactive security, using your own AI for continuous red teaming and vulnerability chaining analysis. Master these, and you can defend the new frontier.
To find related ebook and other material for this training course, go to quicktechie.com. Now you will see all the video courses are available here. So let's move to the ebooks. You can go here, ebooks, all AI related ebooks, like you are watching currently Mythos related training. That ebook would be uploaded under this section. You can download this ebook. PDF would be available, all 300-page PDF. So you just click on the download this entire ebook. You can download from this section. So whatever training you are currently listening, corresponding ebook would be available. We have thousands of ebooks available. Now, other than that, we have on video courses which you are watching right now. This also all AI related courses are available. Similarly, for all company related trainings are available, like Microsoft, you can find it here with their respective certification training modules. All exam simulators which would help you to get the certification preparation. Just refresh if you get this kind of error. Okay, so now you can see these are all certification preparation materials. Will also be click here to the NVIDIA certification preparation material. So you can see all NVIDIA certification preparation materials. Click on any of this and it would load the entire screen and you can launch the practice paper. So this is what you can see, that you can submit the answer. We have an audiobooks available. Okay, so for each section, and these are our alumni who can you can find out all alumni who are accessing our portal.